Alright, so today what we're going to be talking about is we're going to be getting into the introduction of algebra, talking a little bit about some new terms that you might not be familiar with, but we're going to discuss constants, coefficients, variables, and terms, and then we're going to also talk about how to classify polynomials all in one lesson today. So let's start over on the side that says Introduction to Algebra Vocabulary. So on that side, what we're going to do is we're going to fill that in as we go through. So we'll start up at the top where it says equation. An equation, it says a math sentence that states two quantities are, and in that blank we want to go ahead and write in the same. We know that when we have a math sentence that two quantities are going to be exactly the same. And normally it will have an equal sign. Alright, so in that next blank, you can go ahead and write in your equal sign. Now, it goes on to say that the equation says what is on the left is equal to what is on the right. Now, if you look at that equation they have above, we can see that the equation is 3x minus 4 equals 7. So in other words, what is on the left, which is 3x minus 4, is going to be equal to what is on the right, which is 7. So those are going to be your next two blanks that you fill in. And with equations, we know that whatever is on one side is always equal to whatever is on the other side. Whether it be an expression, which an expression would be the entire thing you see on the left side, 3x minus 4, and the number or constant would be 7. So it could be a constant equal to an expression. All right, it doesn't always have to be an expression equal to an expression. Now down underneath that it says parts of an equation. So with parts of an equation we have basically 3 or 4 different parts. I guess you could look at it as 4 different parts. And we'll start with the first one, which is a variable. All right, so I'm going to go ahead and clear this off. A variable, it says, is a letter. So in that first blank you're going to go ahead and write in the word letter. Alright, so it is a letter that represents a number we do not know yet. A lot of times variables will be represented by x's, y's, those are probably the two most common, but you can have really any letter, A, B, C, D, E, so on and so forth. Now, underneath variable it says that we have every variable has a, so in that blank we're going to write in the word coefficient, C-O-E-F-F. I-C-I-E-N-T, coefficient. Alright, so with a coefficient, we're looking at the number in front of the variable. So the coefficient is going to be the number in front of the variable. So when you look at your numbers, you always look, or when you look at your variable, we want to identify the number that is in front of the variable to find the coefficient. And then the last one, or the third one there, is constant. A constant is a number with no variable. Alright, a number with no variable. A number with no variable attached. Alright, so we have our 3 different terms. I think I actually missed one. If you go back up to coefficient, alright, after coefficient, it said it can be positive, so you can write in 2 blanks there. One's positive or negative. Sorry, I forgot that. Okay, coefficients can be positive or negative. And like I said, with constants, we want to make sure constants is a number with no variable attached. Alright, so down there at the bottom, on the last one, it says a term is any of the following. A term can be a constant, a variable, or it can be the product of a number, a coefficient, and a variable. So we have lots of different things we can represent there with terms. So now let's look at a couple of examples and see what we can come up with and what our answer actually ends up being with these. So down at the very bottom, we'll work one together and then I'll let you work one on your own. Let's look at the expression 2k plus 15 minus m minus 3 plus n minus 7p. So here we want to identify the terms the variable, I'm going to do some abbreviating here, the coefficient, and the constants. So first off, let's go through and identify our terms. So really when we look at this, we know the terms is going to be each individual part. So our first term would actually be 2k. So we'll write that in, 2k. Our next term would be positive 15. So we're going to write positive 15. The next term would be negative m. The next term would be negative 3. The next term would be positive n. And then the last term would be negative 7p. Now each one of those represents a term because it's in each individual part of the expression. The variables are going to be your letters. So to find the variables, we're going to look for letters. So the first letter I see here is going to be k. So I'm going to write down k. The next variable I see is negative m. Alright, now here I don't write down the negative because the negative is understood to be a number out in front, a negative 1. So that's just going to be the variable m. We also have the variable n and the variable p. So those would be our 4 variables for this problem. Then we have the coefficients. The coefficients are the numbers in front of the variables. So we have the coefficient of 2. We have the coefficient of, don't forget this one, negative 1. And then we have the coefficient of, positive 1. That one's kind of hidden. Remember, there's always a 1 in front of the n, or 1 in front of something that's just plain. All right? And then the negative 7 that's in front of p. So those would be our coefficients, 2, negative 1, 1, and negative 7. And then lastly, we have our constants, which are our numbers that stand alone. Now those are probably pretty easy to see because we haven't did anything with those except underline them. So here, the only numbers that stand alone are going to be 15 and negative 3. So those are our 2 constants, 15 and negative 3. All right, so really simple problem, just identifying the different parts. Now let's see if you can work one on your own. So in the next example, we have negative 8 minus 4c plus 7 minus c minus 12c minus 2. I want you to see if you can identify the terms, the variables, the coefficients, and the constants. I want you to go ahead and pause the video and see if you can work this problem out now. Alright, welcome back. So let's see what you got for your answers for this problem. So real quick, the terms in this one, each individual part would have been negative 8, negative 4c, 7, negative c, negative 12c, and negative 2. So each one of those would have been terms here. So we can write down each and every single one of those with its sign, and we should be able to identify each individual term. After you've identified the terms, we want to identify the variables, which are the letters. So here we have 2 variables, well, it looks like 3 variables, but they're all the same. So we have a C, and a C. So since they all 3 are the same, the only variable that's used here is C. The coefficients is going to be the numbers in front of the variables. So here we have a negative 4, we have a negative 1, and we have a negative 12. So we have a negative 4, negative 1, and a negative 12. It all worked out to be negative that time, it looks like. And then the last thing would be our constants, which are our numbers that stand alone. So we have the number negative 8, positive 7, and negative 2. So that would be negative 8, positive 7, and negative 2. So a fairly simple problem to work there. Shouldn't have had too many issues with it. Do remember that this is a test question. I know for a fact that this will be a test question, so know how to do this type of problem. If you can identify the different terms, variables, coefficients, and constants, then you should be able to get 100% on the test when you work this problem. Alright, if you flip over your page, on the back of your notes, it also talks about polynomials. Now we're going to move a little quicker with polynomials, but with polynomials, it says the definition is the sum or difference of terms. Alright, it's the sum or difference of several terms. Now, how the terms can be classified is by each word. So the first one it starts off with is monomial. So with a monomial, and I'm going to abbreviate here since you have it on your page, a monomial is going to be basically mono meaning one. So that's going to be a polynomial that has one term. A binomial, that's probably pretty easy as well. You probably can guess that one. A binomial is going to be two terms. A trinomial, once again, that one's pretty easy. A trinomial is going to be three terms. And then after a trinomial, we have what we call a polynomial. Now, a polynomial represents any number of terms. Let's write that out. Any number of terms. So keep in mind that a polynomial could be a monomial, a binomial, or a trinomial. It could even have 4 terms, 5 terms, 6 terms, 7 terms, 8 terms, so on and so forth. So keep in mind that a polynomial is any amount of terms. Now, the degree of a polynomial is a really simple concept. The degree of a polynomial is going to be the highest exponent or power. All right. Oh, forgot my N. All right. It's going to be the highest exponent. So the degree of a polynomial, all right, the degree of a polynomial is the highest exponent. So how do we classify degrees? Very simple. If it has a power of 1 or a degree of 1, then we classify it as linear. So an example for this, and you can write this out beside the example for a linear or a first degree, would be something simple like 3x. Notice how the x is to a power of 1, and we don't have it written there, but it's understood to be to a power of 1. The next one would be a quadratic, which is a power of 2. So an example of a quadratic could be something like 3x squared plus 1. The highest power here would be understood to be 2, which makes it a degree of 2 in quadratic. The next one would be a cubic, which is the third degree. So for a cubic function, an example of that would be 2x cubed minus 2x squared minus 3. Notice how the highest power is 3. And then for a quadric, which that doesn't really happen all that often, I guess, but the highest degree would be 4. An example of that would be something like 3x to the 4th power plus 2x squared plus x. So those are all 3 or all 4 very good examples representing each one of these. Now it also has down there, it says a constant term or number. A constant term has a degree of 0. So an example of a constant term would just be a number, all right? An example of that would be something like -1. It's a constant term. Has nothing associated with it. All right.